Number 17, we need to take what we know about perpendicular bisectors and circumcenters and use that to solve for a missing length here. We're trying to find GA, which is this red line right here, and we're given some information about this. What we know is that all those blue lines are perpendicular bisectors of the triangle. So one thing I would do, I would just give myself a reminder that these are all perpendicular like this. Just because now I can think about what I know about circumcenters. We know that in a plane, if a point is on the perpendicular bisector of the segment, which like point G is, right? It's on this perpendicular bisector, then it has to be equidistant from the endpoints. Okay, so in this case, A and C must be equidistant. And so I'm going to mark those. That one is equal to that one. The nice thing about that is, since this is 11, I can just automatically say this is 11. Okay, and since this is a right angle, this is a right angle. I really have a right triangle in here as part of that, as part of the overall triangle made up of that. I've already solved for GA, haven't I? GA is 11. But I'm showing you this because if we were to go further, we could even solve for DG. We know that in a right triangle, a squared plus b squared equals c squared. And in this case, AG would be our hypotenuse as 11. And we've got one of the sides as 7. And we could solve for DG. That would be like our B value. So we could continue this on. We've already got enough information to recognize GA. That's fairly simple, but we could go further if we need to.